In this video, we'll write the balanced net ionic equation for HNO3 plus KOH. This is nitric acid and this is potassium hydroxide. Both of these are very strong. This is a strong acid, strong base, so this will be neutralization. We'll get a salt plus water. So let's go ahead and first balance the molecular equation. It's already balanced, so that's kind of nice. So we're done with that. We have a balanced molecular equation. Now we need to write the states in. Nitric acid, that's a strong acid. This is one you should memorize. It will dissociate completely, break apart into its ions. So we're going to say it's aqueous. It's going to dissolve in water. KOH, strong base, another one to memorize. That's also going to dissociate completely. So that'll be aqueous. If you know your solubility rules, nitrates are very soluble. In fact, elements in group 1, when they bond, they form soluble compounds as well. So we're going to say aqueous there. And water, that will be a liquid. So we have our states here. Next, we're going to split the strong electrolytes into their ions, and that'll be the complete ionic equation, sometimes called the total ionic equation. Hydrogen's in group 1, that'll have a plus charge. Our nitrate is negative. We have plus 1 because potassium's in group 1, and the hydroxide, that's negative. Again, plus and minus. And then water, that's not an ionic compound, so these are going to stay together. We're not going to split this apart. So to write this out, we'll write H plus, and I'm not going to write aqueous each time. Let's do that at the end. Plus the nitrate ion, NO3 minus, then we have our potassium ion, K plus, and the hydroxide ion, that OH minus. So these are the reactants here. Now for the products, we'll do the K plus, and then the nitrate ion, that NO3 minus. And for water, we're not going to split that apart. So that's going to stay together, H2O. So this is the total or complete ionic equation. So we can cross out what are called spectator ions now. These appear on both sides of our equation, and we cross them out because they don't change. They stay the same, so we're not really interested in that. So I see a nitrate here in the reactants and in the products. Let's cross those out. I also see the potassium ion here in the reactants and the products. Cross those out. And what's left, this is the net ionic equation. We have the H plus, OH minus, and then the water. So I'm going to clean this up and write the states in, and we'll have our net ionic equation for HNO3 plus KOH. And this is the net ionic equation for nitric acid plus potassium hydroxide. This is Dr. B, and thanks for watching.